Hi everyone. In this semester from the course CHO 353A, we have two sections. The first section includes protection and deprotection and the Chiron approach, and the second section includes the carbohydrate chemistry. So from the first section we have completed the protection and deprotection, and now we are going to start the Chiron approach. So this Chiron approach is also for the 12 lecture topic. So why there is a need to study the Chiron approach? Because in this Chiron approach topic we are going to synthesize some natural products in laboratory. So why there is need to synthesize these natural products? Because these are act as a drug or act as a medicine. Therefore there is a need to synthesize some natural product, and the approach for the synthesize this product is used is the Chiron approach. So what is the Chiron approach and why it is important? Because in practice of organic synthesis, as it is related to the natural product, in this Chiron approach we are going to synthesize the natural product in laboratory. So there are some 6 to 7 molecules which we are going to synthesize by the Chiron approach method. So the word Chiron, what is the Chiron? It is a combination of the words chiral and synthons. So you come across the word synthons in the retrosynthesis, okay, and here the combination of two words, that are the chiral and synthons, and it represents a small chiral building blocks. For example, the amino acid, terpenes, carbohydrate, the hydroxy acids are the chiral building block, which are also called as a chiral precursor, and with the help of this starting material we are going to synthesize these natural product or these molecules. So the meaning of the chiron is the chiral plus synthons, means the synthons which we have to use are the chiral compound, okay, and the symmetric form of the naturally available, cheap, optically pure and the operationally versatile starting material like the amino acid sugar preparation is called as Chiron approach. So simply, what is the definition for the Chiron approach? The symmetric form of naturally available. Okay, we are going to synthesize the natural product. Therefore, we use the chiral precursor which also the naturally available. Okay, so the symmetric form of the naturally available, cheap, then optically pure and the operationally versatile starting material like the amino acid sugar preparation is called Chiron approach. In short, here we use the strategy where we using the carbohydrate as a starting material for the synthesis of new chiral compound, and the starting material which we are going to use are the naturally available and also they are optically pure, and these are the chiral compound. So this all is called as a Chiron approach. So here for the synthesis in organic chemistry we use the retrosynthesis concept. We all are familiar with the retrosynthesis. So what is the retrosynthesis? It is an imaginary but logical reverse chemical reaction, okay, in which help us to reach the reactant starting from the target molecule, or it is also called as it is nothing but the backward manipulation of the target molecule. Means the molecule which we have to synthesize is called the target molecule, okay. And what is the retrosynthesis? It is an imaginary but the logically reverse chemical reaction. In synthesis, we do some the reaction in which there are some two reagents, and we carry out this reaction and we got the our desired product, okay. There are many conditions and reagents are used. It is called the synthesis. And what is the retrosynthesis? It is an imaginary but logical reverse chemical reaction which help us to reach the reagent or a reactant starting from the target molecule. Means in retrosynthesis we got the starting material from which we synthesize our target molecule. So it is nothing but the backward manipulation of target molecule. And what is the target molecule? The molecule whose synthesis being planned. This is called the target molecule. And one more concept in this topic, the retrosynthesis analysis. The retrosynthetic analysis means what? The process of breaking down the target molecule into a convenient starting material using the disconnection and the FGI. Means it is the process of breaking down the target molecule into convenient starting material using the disconnection and FGI. FGI means the functional group interconversion. So by using the functional group interconversion and the disconnection of target molecule, we get some molecule that are the we get the starting material. So this is called as a retrosynthetic analysis. So here are two types of approaches, the retrosynthetic analysis, retrosynthesis and the Chiron approach. These two approaches are the different because in the retrosynthesis the starting material which we have get are sometimes the chiral or not chiral, or it is naturally available or not. But in Chiron approach the starting material which we have to use are the chiral compound. Therefore it is called the Chiron approach. So here are some points. In the retrosynthetic approach, the different molecular synthesis by using their synthetic equivalent, that is the synthons. So what are the synthons? The synthons are the starting material which used in the retrosynthetic approach. While in case of the Chiron approach, the natural product or a target molecule are synthesized by using the special compound by carbohydrates, amino acid, hydroxyl acid, etc. Means in the Chiron approach, the starting material which are used are the chiral compound, as well as these compounds are the natural product or naturally available, optically pure. For example, the carbohydrates, amino acid, hydroxyl acid, terpene, etc. are the natural product, and by using this natural product as a starting material, we are going to synthesize some natural product or the natural molecule. So this process or this approach is called a Chiron approach. And in the retrosynthetic approach, the synthetic equivalents are not necessarily chiral compound. Means in the retrosynthesis, the synthons or the synthetic equivalents is not necessary that are the chiral, or it is maybe not chiral compound. Okay, but in the Chiron approach, the synthetic equivalents are chiral compound. So these are the difference between the Chiron approach and the retrosynthetic approach. So what are the advantages of Chiron approach over retrosynthetic approach? See here, in a Chiron approach, the synthetic equivalents are chiral, naturally occurring organic compound. Hence, it directly gives the access for the synthesis of natural product. So if we want to synthesize the natural product, then the starting material is also naturally occurring or chiral compound. So in Chiron approach, the synthetic equivalents are the chiral, naturally occurring organic compound. Therefore, by using this starting material, we got the natural product. Okay, and the Chiron starting material, that is the precursor, is active intermediate which can be easily used for the synthesis of different target molecule having the chiral center. Means what? The natural product which is synthesized, that have some chiral center. Okay, and the precursor, that precursor are also the chiral compound and they are naturally available. Therefore, both the precursor and the target molecule both have the chiral centers. Okay, so these chiron are having the chiral center with either R or S configuration. This may be R configuration or S configuration. For example, the chiral precursor can be utilized in the synthesis of natural product such as a biotin. The biotin is a natural product. So for good synthesis, following points should be considered. First one is a cheap starting material. The starting material which is used is cheap, then reasonably efficient with few steps. In the cost effective, it should maintain all the chiral centers from starting material. Then the easy protecting and deprotecting conditions. These are the things for the good synthesis and easy separation by column chromatography. So the Chiron approach, how we can define the Chiron approach? It is the symmetric form of naturally available, cheap, optically pure and operationally versatile starting materials like the amino acid, carbohydrate and sugar preparation called as the Chiron approach. So in this Chiron approach, we are going to synthesize some natural product. The structure for these natural products, here we have a L-alanine, that is the amino acid, then the pentenomycin, shikimic acid, multistriatin and the S-propanediol are the natural product which we are going to synthesize by using this Chiron approach. So what is the target? Target means the molecule which is going to synthesize, that is called the target molecule, and here it is a chiral precursor. Means what? From the target we achieve the chiral precursor by different methods. The first one is a functional group interconversion. So what is the functional group interconversion? In a target molecule there are some functional group, okay, and in the chiral precursor the functional group, sometimes some functional groups of this target molecule can be converted into other functional group for the synthesis, and we got some starting material that is called the chiral precursor. So it is an important step for the retrosynthesis, or we can say the Chiron approach, that is the functional group interconversion. So the functional group present can be manipulated as per requirement. Then the second thing is carbon framework. So what is the carbon framework? Carbon framework means what? In the natural product that are for example the carbohydrate, amino acid, then terpenes, hydroxy acid, the number of carbons are different. Therefore the patterns and shape of 6 or 5 member cyclic or a open chain form. It may be cyclic or a open chain form. The number of carbons may be variable. This is called the carbon framework. Then the flexibility of carbon framework available, that is the easy to make 6 or 5 member cyclic open chain molecule with the number of carbon atom as per requirement. Then the next thing is a stereochemistry. So the cyclic sugar derivative can be functionalized at predetermined site based on the consideration of steric control, stereo and the stereoelectronic control. The second thing in the stereochemistry is the modified derivative are then converted into cyclic or acyclic derivative which consider with the target structure. The further manipulation is may be necessary to assemble the entire molecule. Then the one more thing is important in this Chiron approach is the chiral pool strategy. So the chiral pool strategy is the collection of cheap, readily available, pure natural product, usually the amino acid or a sugar, from which the pieces containing required chiral centers can be taken and incorporated into the product. Means what? This is the strategy to convert the starting material into the product, and the starting material are the cheap, readily available and the natural product. For example, the amino acid, then the carbohydrate which contains the chiral center, and the product which is also contain the chiral center. A more economical way of making compound as a single enantiomer is to manufacturing by using an enantiomerically pure natural product as a starting material. So if you want to make the single enantiomer, then the starting material is also the enantiomerically pure natural product is used rather than just using the one as a resolving agent. This method is known as a chiral pull strategy. So the basic concept of this Chiron approach are the chiral precursors. So in short, for the synthesis of a natural product, here we use the starting material, that is called the precursor, or the chiral precursor. Means what? The starting material are the chiral compound, and which is also the naturally occurring. Then it is a chiral and also optically pure compound are used as the chiral precursor. So there are carbohydrates are used as the chiral precursor. Then the amino acid, then hydroxy acids and the terpenes. These are used as the chiral precursor because these are the chiral compound. So what are the chiral compound? Those compound shows the optical activity are called as the chiral compound. So carbohydrate, amino acid, hydroxy acid, terpenes, in which there are chiral centers available. Therefore those compound are shows the optical activity. So what is the optical activity? The optical activity is one of the physical property which shown by the organic compound, and it can rotate the plane polarized light either left hand side or the right hand side. This is called as the optical activity, and the optical activity can be determined by using the instrument called as the polarimeter, and the optically active compound must be chiral. So chiral means what? The carbon atom containing the 4 different atoms, it is called the chiral compound, and the optically active compound must be chiral compound. Okay, so these carbohydrate, amino acid, hydroxy acid and the terpene are used as the chiral precursor for the synthesis of natural product because these compounds are the chiral compound and which are the optically active. Hence it is used as a chiral precursor for the synthesis of natural product in the Chiron approach. So most of the drugs are the chiral in nature, hence we use this as a chiral precursor. So chiral precursor means what? The starting material used to synthesize a target molecule in organic chemistry. For the synthesis of a molecule, the starting material availability and also cost is also important in the synthesis. Cost in the market is also the important. So the carbohydrate, amino acid, hydroxy acid, terpenes are the chiral precursor. These are the natural compound and this shows the chirality. That's why by using this chiral precursor we can prepare the molecule, shows the biological activity, that is the target molecule. So here the carbohydrate, amino acid, hydroxy acid and the terpenes shows the property. First the carbohydrate, the carbon framework in the carbohydrate are, it may be cyclic, then the combination of a cyclic and acyclic, and it contains the 3 to 7 carbon atoms. Asymmetric center, that are the chiral centers in the carbohydrate, are 1 to 2 or it may be 6, include the anomeric carbon. Sense of the chirality, the 2 raised to n permutation, generally the D configuration shown by the carbohydrate. Then the fourth one is a sequential functionality. So the alpha hydroxyaldehyde, then the alpha amino aldehyde, polyol and the amino alcohol, etc. In case of the amino acids, the carbon framework is generally acyclic except the proline. Then the 3 to 6 carbon atoms are present in amino acid. The asymmetric centers for the amino acid are generally 1 or 2. And it present generally or a naturally L configuration, that are the alpha amino acid or a alpha amino beta substituted acids. The third one is a hydroxy acid. This is also natural product. The carbon framework, it contains acyclic or a 3 to 7 carbon atoms, in which 1 to 2 asymmetric center, that are the chiral centers, are present in the hydroxy acids. It may be R or S combination. These are the alpha hydroxy acids or a alpha beta dihydroxy acids. Then the next one is a terpenes. The terpenes are acyclic or a cyclic. Generally, 1 or 2 asymmetric centers are present, and it may be R or S configuration. And these are the alpha substituted ketones. So the next important point is a chiral templates. So what are the chiral templates? The carbon framework, which are an exact copy of a segment of target and have its inherent natural chirality, which can be related to the original stereo code of a target, are called as chiral templates. Means what? The chiral template, it is a part of the target molecule. Okay. So here we write the carbon framework, which is an exact copy of the segment of a target, and it's have the natural chirality. That means the chiral templates are the naturally chiral compound. So here we have an example. This is the target molecule, and here we do the functional group interconversion. Then we get this chiron, and after we got a starting material, that is a chiral template. So this is the chiral template of this target molecule. Here you can see this is this part of the target molecule, which is exactly same in this chiral template. Here one more example. This is also the chiral template of this target molecule. The chiral templates can be shown in the concept of the retrosynthetic analysis of target structure in the pictorial form by using the Chiron approach. You can see here, this is in this picture, this is the target molecule. Here we have these two triangles which are the in white color. This is the target molecule. Okay. And this is the chiron of this target molecule, and these are the chiral precursor. Means what? The chiral precursor or a chiral templates are the exact segment of this target molecule. So by using this chiral precursor, we synthesize this target molecule. So the synthesis by using the chiral approach of the following molecule. So in this chiral approach, we are going to synthesize these molecules. The first one is the glyceraldehyde. This is the structure for glyceraldehyde. Then the S-propanediol. Then the R and S epichlorohydrin. These are the R and S epichlorohydrins. Then the multistratin. This multistratin, L-alanine, pentinomycin, and the shikimic acid. So all these molecules which we have to synthesize by using this Chiron approach. So these are this compound which are the natural product. Okay. So these compound act as a medicine. Therefore, there is a need to synthesize this molecule, and we can extract this type of compound from the plant or a nature. And also in modern rich laboratory can synthesize these natural product. So for the synthesis of natural product, what type of precursor we are going to use? Specifically, those are the present in natural can be used for this synthesis. So in natural product synthesis, the starting material or the chiral precursor are going to use that are the naturally occurring chiral, and the optically pure compound is used for the synthesis of these natural product. And so the carbohydrate, amino acid, terpenes are the naturally occurring chiral precursor. Hence, we use the carbohydrate or a amino acid for the synthesis of this natural product. And generally, the amino acid present in the L configuration, while the carbohydrate naturally occur in the D configuration. It is related to the OH group present in that carbohydrate. Therefore, for the synthesis of natural product, the what type of precursor we are going to use? Specifically, those are present in the nature can use for the synthesis. Therefore, we use the carbohydrate, amino acid, terpenes, and the hydroxy acid for the synthesis of these natural products. I hope you understand what are the chiral approach and the chiral templates and also the chiral precursor, and what is the advantage of the Chiron approach over the retrosynthetic analysis. So in next lecture, we are start the synthesis of this natural product, and which is starting the glyceraldehyde. I hope you understand. Thank you for watching.